This is the first video of 3 for lesson 8. In this particular video, we're going to look at a table and explore what makes a relationship quadratic. Just like we have with linear and exponential, this video will show you how to tell that from a table of points. So let's look at this table of points. Just like we did with the other types of equations, we're going to determine the rate of change. So in here, you have to make sure that your x's are changing by ones. And then for your y's, or your functions, you're going to start looking for a pattern. So I noticed that from one to the next, I start seeing a pattern of first I am subtracting by increasingly smaller numbers, and then at some point I start adding by the same number. So +1, +3, and +5. You see that pattern? And that is very typical and representative of what we would call a parabola, right? Because once it gets to the bottom or the very top, then it starts reversing. And then what we see also, if we try to look for a second level of change, is that the second level of change is actually identical. So from one to the other, whether you're subtracting or adding, you're going to add 2 at that second level of change. So it's going to be the same. And this is the number one typical way of knowing if a table of points is representative of a quadratic. You're going to have 2 levels of change, and that second level of change is going to be the same for each point. In graph B in the bottom, you're seeing that I'm starting to look for those changes as well in the Y column. And what I'm noticing is that the second level of change is actually the same. So this would also be a quadratic, and it's actually subtracting. So we have 2 levels of change. They follow the pattern. One is positive for graph A, one is negative for graph B, and you can see that being represented in the graph. So the parabola that opens up, where you have a minimum point in the bottom and it opens up, is going to be positive, and so your second rate of change is positive. And the opposite for the B, it's opening down, and you see that your second level of change is negative, which means it has a negative leading coefficient.